Okay, today we are talking about the chain rule, lesson 3.6, the chain rule. If you look at this first equation here, I say, how do we differentiate y equals the sine of the quantity x squared minus 4? Hopefully you can see that this is a little bit more complex than the problems that we've had in the past. So if we look at this, we have to find a better way to figure out how to differentiate y equals sine of the quantity x squared minus 4. We need what's called the chain rule. So the first thing I'm going to do is show you this video. On the chain rule.
Now it's time to learn one of the most important derivative techniques. In one form or another, you'll be using this for the rest of the calculus year, so it's about time we started using it. It's called the chain rule. And let's begin by taking a look at an example. If you're going to try to find the derivative of sine of x, you probably know already that the answer is cosine of x. However, if you want to find the derivative of sine of 3x, well, let me tell you something, it's not cosine of 3x. It's close, but it's not quite right. The problem is that there's a 3x inside that sign instead of just a plain old x. You see, whenever a function contains something other than just plain old x, you need to use the chain rule to find the derivative. Now, in fancy math terms, when a function is inside another function, for example, in this case, 3x is inside of sine, we call that a composition of functions. So the chain rule is used to find derivatives of composition of functions. Or, less technically, use the chain rule to find the derivative of something if it contains something besides just plain x. Alright, let's take a look at the chain rule in action. We're going to find the derivative of f of x is equal to sine of 3x, which according to what you just watched is definitely not going to equal cosine of 3x. Well, first of all, we have to take a look at the functions here. Well, there's two of them. There's sine and there's 3x. The chain rule is going to tell us what order the derivative has to occur. I mean, obviously we're going to have to take the derivative of sine somewhere and probably the derivative of 3x somewhere. But we need to learn what order that's going to happen in. And the chain rule does that for us. But before we get into that, we need to think about something. We need to decide which of those two functions, sine and 3x, is the inner function and which is the outer function. Well, it's not too hard to decide that 3x is definitely inside of sine, so therefore 3x is the inner function, and sine is the outer function. So now it's time to take the derivative. The chain rule tells me that when I find a derivative, I start with the outer function, and I derive it. So the derivative of sine is cosine, but here's the trick. I leave that inner function alone. So far, my answer is cosine of 3x. But now that I'm finished with the outer function, I can finally take the derivative of the inner function, and the derivative of 3x is 3. So my final answer is the derivative, or f prime of x, is equal to 3 cosine of 3x. Now I know this is a little tricky, so let's go ahead and do another example. We'll find the derivative of g of x is equal to the natural log of x cubed. Now in this case, once again,
Real quick, let me show you that when we have the derivative of natural log, we haven't done those yet, but the derivative of natural log is 1 over x. So that's something we'll learn here in a few lessons, but the derivative of natural log is going to be 1 over x.
we see two functions, the natural log of x and the cubic function. So we have to decide which is the outside and which is the inside function. Well, it's even easier in this case to tell which is the inner function, because the inner function is actually enclosed inside parentheses. So our inner function is natural log of x, and our outer function is the cubic function. So let's find the derivative according to the chain rule. Remember, when we take the derivative, we start with the outside. So what's the derivative of something to the third power? Well, according to the power rule, it's 3 times something to the second power. Now, what is that something? It's that inner function, and it's going to be left alone. We took the derivative of x cubed, in other words, a very simple derivative. But that natural log of x stays untouched until now. Now that we're finished deriving the outside function, we move on to the inside function, and the derivative of natural log of x is 1 over x. So we multiply that new derivative by the derivative we got a second ago, and our final answer is going to be 3 times natural log of x, the quantity squared, all divided by x. And that's our derivative according to the chain rule. So now let's look at the official or scary math definition of the chain rule. It says if we're given a function, h of x, which is equal to f of g of x, in other words, h is the composition of the two functions f and g, then the derivative will be equal to the derivative of the outer function, or f prime, leaving the inside function alone, g of x, times the derivative of the inside function.
Okay, so here's the chain rule, and I know it looks crazy, but this right here should have an equal sign between these two. There should be an equal sign right here. And if we want to find the derivative of this, if we want to find the derivative of f of g of x, or f of g of x, the derivative, it's the derivative of the outside, which would be f, or leave the inside alone, times the derivative of the inside. So that's the chain rule. Again, in simple phrases, it's the outside-inside rule. Derivative of the outside, leave the inside alone, times the derivative of the inside. So if we go back to this example that I gave you earlier, I said find y prime if y equals sine of x squared minus 4. So y prime would be, what's the inside function, what's the outside function? Well, hopefully you can see that this would be the inner function, x squared minus 4, and sine is going to be our outer function. So, according to the chain rule, derivative of the outside. So derivative of sine is cosine. Leave the inside alone times the derivative of the inside. So derivative of x squared minus 4, 2x. Now we make it pretty. 2x cosine of x squared minus 4. That's the derivative of sine of x squared minus 4. That's the chain rule. And we have to use the chain rule a lot. There's a lot of complex problems. They're not going to be as straightforward as they have been in the past. Let's keep going and see how we do some of these. Okay, this is Leibniz notation. If y equals f of u and u is g of x, then dy dx is, look, it's the derivative of the outside times the derivative of the inside. We very rarely will you see this notation. Okay, find dy dx for the following. Very similar, remember one, to the one we just did. So dy dx will be, this sine would be our outer, x squared plus 2 would be our inner. So the derivative of the outside, cosine, leave the inside alone, times the derivative of the inside, which would be 2x. So this would be 2x cosine of x squared plus 2. Find the inside, find the outside, derivative of the outside, leave the inside alone, times the derivative of the inside. Problem 2. Y equals cosine of x squared plus 3x, all minus 1. So we're finding dy dx. We actually have two terms here. We have cosine and we have minus 1. So we're going to need to use the chain rule for cosine. Cosine would be our outer function, and x squared plus 3x would be our inner. So, derivative of the outside, negative sine. Leave the inside alone, times the derivative of the inside would be 2x plus 3. Minus the derivative of 1 is 0. Now make it pretty. Negative 2x plus 3 times sine of x squared plus 3x. That would be our derivative. Okay, now we have problem 3. Y equals tangent of 5 minus sine of 2x. In this problem, we actually have the chain rule twice. Look, first we have the tangent function, which would be our outer function. Then we have 5 minus sine of 2x, which would be our inner. But look at this. Sine of 2x right here, wouldn't this be sine of 2x like this in parentheses? So in our second step, sine will be the outer and 2x will be the inner. So we're going to have to do the chain rule twice. So first we'll start with the most outer function. So dy dx equals the derivative of tangent, secant squared. Leave the inside alone. Times the derivative of the inside. So now the red inside. 0 minus the derivative of sine now. Now we do the outer, leave the inner alone. So the derivative of sine is cosine. Leave the inside alone, but again, times the derivative of the inner. Times the derivative of 2x is times 2. So look at that. This right here was the outside, leave the inside alone, times the derivative of the inside. Then we had the derivative of the outside, leave the inside alone, times the derivative of the inside. So we did the chain rule 2 times there, really. Now let's make this pretty. I'm going to make this negative 2 cosine of 2x times secant squared of 5 minus sine of 2x. Just making it pretty, a little nicer to look at. Digest that one. That one had the chain rule inside of the chain rule. Okay, now we have the power chain rule, and we all know that if I give you the equation y equals x cubed, y prime would be 3x squared. Well, now we're going to look at it where this x is not just a plain old x. It's going to be a lot more involved. So let's look at number 4. Y equals tangent cubed of 4x. Hopefully you can all see that this is the tangent of 4x, the quantity cubed. Do you understand that tangent cubed means that it's the tangent of 4x, the quantity cubed? Can you also see that we're going to have multiple chain rules again? We have the outside function of 3. We have the inside function of tangent. But then we have tangent and 4x. Tangent would be the outer the second time. 4x will be our inner. So again, we're going to have 2 chain rules here. So here we go. Y prime will be derivative of the outside. When we take the derivative of a cubic function, it's 3x squared. So it's going to be 3, leave the inside alone, squared. Bring out the 3 to the 1 less, leaving the inside alone. Times the derivative of the inner, so now we're taking the derivative of this. The derivative of tangent is secant squared. Leave the 4x alone. Times the derivative of 4x. 4. Make it pretty. 3 times 4 is 12. Tangent squared of 4x, secant squared of 4x. Digest that, see if that makes sense. Digest that, see if that makes sense. Problem 5. Any idea what's going on here? Y equals the sine of 3x times 4x plus 7, the quantity cubed. This time we're working with a product as well as the chain rule. so stay with me. We're going to do the product rule. All of those rules still apply. So 1 d2 times, okay, derivative of 4x plus 7, the quantity cubed. So this is chain rule. The 3 is the outer function, 3. Leave the inside alone to the 1 less. Times the derivative of the inside, which is 4. 1 d2 plus 2 d1. Derivative of sine, cosine, leave the inside alone, times the derivative of the inside, which would be 3. Now we make it pretty. 3 times 4 is 12. 4x plus 7, the quantity squared, times sine of 3x, plus 3, 4x plus 7, the quantity cubed, cosine of 3x. Hopefully you can see what's happening there. And what I would like you to do, look at problem 6. It says an object moves along the x-axis so that its position at any time t greater than or equal to 0 is given by x of t. Find the velocity of the object as a function of time. I want you to do this. Remember, velocity is derivative of position. They gave us the position function. Find the velocity for problem 6. Problem 7, I also want you to try. I want you to find the derivative. Find d dx. Find the derivative. And then finally, I also want you to try problem 8. Find ds dt. There is something extra going on here. This one's not just the chain rule. Make sure you look at this problem 8 carefully. So your assignment now is to try 6, 7, and 8, and then complete the lesson check.